On the Perplexing Polynomials, a math game show where three idiots try to get their answers correct. What is the expression that shows the area of the trapezoid shown?
I got it.
Bennett Hagley, your answer is correct. Props to Bennett for getting this answer right. Pretty simple way to solve this problem. Hey guys, if you want to try out the problem for yourself, go ahead and pause this video. The area of a trapezoid is 1/2 the first base plus the second base times the height. So we have our two bases here, x plus 2 and 3x plus 8. And our height is simply x, and it's half of that. And we just simply solve. Parentheses first, which you get 4x plus 10 times x into half. We'll distribute the half first. So you get 2x plus 5 multiplied by x, and you just distribute x. 2x squared plus 5x. And that's the area of the trapezoid. Don't forget your units. Since there's no unit specified, we'll just keep it as unit squared. A small soup can has a diameter of 3 inches and a height of 5 inches. A larger soup can increases diameter by x inches and the height by 2x inches. What is the lateral surface area of the larger soup can?
I got it.
Yankee, your answer is correct. Alright, so let's get to explaining this problem. Hey guys, if you want to try out the problem for yourself, go ahead and pause this video. A small soup can has a diameter of 3 inches and a height of 5 inches. A large soup can increases diameter by x inches and increases the height by 2x inches. Write an expression that represents the lateral surface area of the soup can. So here I already drew out the soup can, and the diameter, as they said, of the large soup can was 3 plus x inches. And the height of the large soup can, they said, was increased by 2x inches. So it was already 5 inches, so we add 2x. And the lateral surface area of the soup can is only this curved surface you see right here. So the circle doesn't really count. So the formula for the circumference of a circle, because it's like the edge of the soup can, is diameter times pi. So we already have a diameter here. We're just going to add pi to it. So pi times 3 plus x. And then we need to multiply it by the height to get the lateral surface area of the soup can. So it's 5 plus 2x. And then we simply just multiply it out. I'm choosing to FOIL this because it's pretty simple. As you all know, the FOIL method. First outside, inside last. And then we simply distribute pi to all the numbers inside the parentheses. And there is your answer. That is the lateral surface area of the large soup can. A rectangular design has a dimension shown. If a small area is removed from the rectangle, what is the remaining area?
I got it.
Yankee, your answer is correct. Alright, so let's get down to explaining this problem. A rectangular design has the dimensions shown. If If a small area represented by a small rectangle is removed, what is the remaining area? Well, this question is pretty simple. Hey guys, if you want to try out the problem for yourself, go ahead and pause this video. So, the area of the big rectangle is 11x times 6x plus 2, and you subtract the smaller area from the bigger area, which is 4x times x plus 1. And then simply solve. So I'll distribute the 11x. 66x squared plus 22x minus, I'll distribute the 4x on this side. 4x squared plus 4x. Oh wait, this is a subtraction, so my bad. And then we solve. We combine like terms. So 66x squared minus 4x squared is 62x squared. And then 22x minus 4x is 18x. And then we'll just put units squared, just to put units on it. And that's the area of the shaded portion of the rectangle. You want to make a cardboard box. You take a 12-inch by 12-inch piece of cardboard and you cut an x by x inch square out of it. And then you fold up the sides. What is the expression for the volume of the box?
I got it.
Frank, your answer is correct. Alright, so let's get down to solving this problem. You want to make a cardboard box. You take a 12-inch by 12-inch piece of cardboard and cut an x by x inch square out of each corner. If you fold up the sides to make your box, what expression represents the volume? Hey guys, if you want to try out the problem for yourself, go ahead and pause this video. So, volume is equal to length times width times height, right? So, we need to figure out the length, width, and height of this box. Well, the height of the box is obviously x. The length of the box will be 12 minus x, because you have to take into account the two corners that were taken out. And the width will be the same. So it will be 12 minus 2x. And all we have to do simply now is multiply it all out. So we'll FOIL this. Not 2, it's 4. 4x squared. And multiply this by x. So you get, I'll just rearrange these in a different way because I like it better. You get 4x cubed minus 48x squared plus 144x units. Nope, not units, inches. Squared. That is the expression. That is the volume of this box. A fountain has a diameter of 10 feet. City engineers want to build a sidewalk around the fountain that is x feet wide. What is the total area of the fountain and the sidewalk?
I got it.
Frank, your answer is correct. Alright, so let's get down to solving this problem. The diameter of a circular fountain is 10 feet. City engineers want to build a sidewalk around the fountain that is x feet wide. Write an expression that shows the total area of the fountain and the sidewalk. Hey guys, if you want to try out the problem for yourself, go ahead and pause this video. So, the diameter of the fountain is 10 feet, and the width of the sidewalk is x feet. So, the area of a circle is pi r squared. So we take half the diameter, and then don't forget we have to add the x for the sidewalk. And then we have to square it. And we multiply it by pi, because we don't want to forget this pi. And then we simply FOIL this, and then multiply everything by pi. So, I'm just going to FOIL this in my head. squared. Multiply this by pi. And you get pi x squared plus 10 pi x plus 25 pi feet squared. And that is the expression that represents the area taken up by the fountain and the sidewalk.
Thank you for watching this video, and we hope you enjoyed.